In the silent reaches of space, something began to glow. Not the fiery burn of a star, nor the faint shimmer of sunlight on ice. This was different. A pulsing light, steady, deliberate, almost alive. Astronomers first noticed it while tracking 3I/ATLAS, an interstellar object speeding through our solar system. At first, it was dismissed as just another comet, another cosmic rock drifting between stars. But then the James Webb Space Telescope caught sight of something that shattered those assumptions. This wasn't reflected sunlight, it wasn't scattered dust. It was light that shone from within, engineered, intentional. At first, scientists called it a glitch, maybe dust interference, maybe bad calibration. But the glow didn't fade, it grew stronger. And the deeper Webb looked, the stranger the truth became. So, what exactly did James Webb uncover? And why has the scientific community fallen into quiet panic? Stay with me, because what you're about to hear may change everything we thought we knew about who or what is out there. From the start, 3I/ATLAS raised suspicions. Sure, it moved like a comet. Yes, it followed a classic interstellar path, but its brightness was all wrong. At over 400 million kilometers away, it shone at magnitude 16.4. Not dazzling by astronomical standards, but far too bright for an object of its size. Astronomers scrambled for answers. Maybe it was larger than estimated. Maybe it was throwing off massive clouds of dust. Maybe it was just an extreme outlier. But Webb's deeper scans told a different story. This wasn't reflected light at all. It was emitted light, radiating from the object itself. That alone breaks the rules of astrophysics. Natural bodies don't generate visible light unless they're stars or burning at thousands of degrees. But Atlas wasn't hot enough, and its spectrum didn't match any comet signature ever recorded. Harvard astrophysicist Avi Loeb, who once suggested that Oumuamua might be an alien probe, stepped forward again. Ridiculed for years, he's now backed by physicist Eric Quito. Together, they modelled ATLAS's light curve. Their conclusion? The glow fits far better with an artificial energy source than any comet theory. Its trajectory only deepens the mystery. Atlas isn't wandering randomly, it's moving with precision. Its path lines up with the ecliptic plane, the very plane Earth and most planets orbit. More disturbingly, its flyby brings it unnervingly close to Earth, Mars and Jupiter, and during its closest approach, Earth will be hidden behind the Sun, unable to observe directly, almost as if the timing was intentional, almost like it was designed to slip past unnoticed. Some theorists believe its dust halo may not even be natural. It could be a swarm of nanomachines harvesting interstellar material for fuel. Similar unexplained phenomena have been spotted before, like the sudden disappearance of dust rings around distant stars. Could ATLAS be doing the same? Then came the chilling discovery. In the radio spectrum, Webb detected a faint rhythmic signal. Not random, not noise. A repeating sequence every 7.2 hours. Too structured to be natural, too deliberate to ignore. Meanwhile, Japanese astrophysicist Laura Jen noticed something even stranger. The light pulses weren't random flickers, they were binary. On, off, structured, repeating. Over time, the sequences formed patterns eerily similar to early computer codes from the 1970s. It's as if Atlas tailored its message to match human technology, as if it has been watching us, learning our digital language, preparing to speak in a way we'd understand. This isn't the first time light anomalies sparked fear. In 1979, satellites detected a mysterious double flash over the Indian Ocean, the Vela incident. For decades, it was dismissed as nuclear testing or cosmic bursts. But now, comparing those signals to ATLAS's pulses, researchers found shocking similarities. The strangeness escalated when Webb recorded something impossible, a negative energy field trailing behind Atlas. Instead of radiating warmth, it dragged ultra-cold vacuum with it. This matches only one theoretical model, warp drive physics. If true, ATLAS isn't moving through space, it's bending space around itself. That explains its acceleration, its silence, its glow without heat. And it raises the most unsettling question of all. Where did it come from? And is it already here? Webb also captured ghost trails, filament-like lines behind the object, structured, layered, geometric. Not natural dust, not random scattering, more like a navigation grid or a path left behind for something else to follow. And then came the blackout. For 47 minutes, Webb's instruments simply stopped transmitting data on Atlas. No malfunction, no interference, just void. When the feed resumed, the object's trajectory had shifted ever so slightly. The final blow came when Webb detected Atlas reflecting Earth's own broadcasts, our radio, our television, our digital noise, remixed and mirrored back toward us, twisted into patterns, reshaped into symmetry, as if something out there was holding up a mirror. In the vast silence of the cosmos, ATLAS isn't just glowing, it's speaking. Not with sound, but with light, with pulses, with reflections of our own voice. And perhaps it wanted to be seen all along. The James Webb Telescope may have done exactly what it wasn't supposed to do: look too closely, not just observing, but triggering a response. And that leaves us with one haunting question. If ATLAS has acknowledged us, what happens next?